Assalamu alaikum. I am Shanda Fatma from MS Chemistry Batch 4, and today the topic of my presentation is Ftir transformed infrared spectroscopy. First of all, we will learn about what is infrared region. Infrared region lies between the visible and microwave portions of the electromagnetic spectrum. Infrared waves have wavelengths longer than visible but shorter than microwave, and their frequencies will be lower than visible and higher than microwave. The infrared is actually divided into three regions: near, mid, and far infrared. Near infrared refers to the part of the infrared spectrum that is close to visible light, and far infrared refers to the part that is close to microwave region. And mid infrared lies between these two regions. Range will be 10 to the power minus 4 to 10 to the power minus 6 meter. The primary source of infrared radiation is thermal radiation. Heat is the primary source of infrared radiation. It is radiation produced by the motion of atoms and molecules in an object. These radiations are produced by motion of atoms. The higher the temperature, the more the atoms and molecules move and more infrared radiation they will produce. Any object radiates in the infrared, even an ice cube emits infrared. FTIR. In FTIR, IR radiation is passed to a sample. Some of the infrared radiation absorbed by sample and some of them transmitted by sample are passed through by the sample. The resulting spectrum represents the molecular absorption and transmission by sample, creating a fingerprint of the sample. Like a fingerprint, no two unique molecular structure produce the same infrared spectrum. This makes infrared spectroscopy useful for several types of analysis. This is the FTIR instrument. Now, principle. Fourier transform spectroscopy differs from conventional spectroscopy in that all of the resolution elements or wavelength intervals for a spectrum are measured simultaneously. Now, what information can FTIR provide? It can identify unknown materials, and it can determine the quality or consistency of a sample, and it can determine the amount of components in a mixture. FTIR was developed in order to overcome the limitations encountered with dispersive instruments, mainly the scanning process. A solution was developed which employed a very simple optical device called an interferometer. The interferometer produces a unique type of signal which has all of the infrared frequencies encoded into it. The signal can be measured very quickly. Usually, we can measure the signals in seconds. Working of instrument. FTIR instrument uses an interferometer which consists of following parts: source, beam splitter, two mirrors, laser, and detector are the parts of interferometer. Firstly, the energy goes from source to beam splitter, and then this beam splitter will split it into two parts. One part transmitted to a moving mirror and other is reflected to a fixed mirror. The moving mirror moves back and forth at constant velocity, and as the result of these, two beams are reflected from the mirrors and recombined back at the splitter, generating an interference pattern transmitted through the sample compartment to the detector. And detector will detect this signal, and after these waveform or interferences will move towards readout, and this will tell us about the sample signals. This is the working of FTIR. Now, FTIR applications. FTIR generally used in identification of an organic compound, structure determination of compounds, study of chemical reactions, study of complex molecules, and conformational analysis. Advantages of FTIR. FTIR instrument is simple mechanical design. It is powerful data station. It is sensitive, fast, and easy to operate, and relatively inexpensive and provides rich information. Top of all, majority of molecules in the universe absorb mid-infrared light, making it a highly useful tool. It has also some disadvantages, which are it cannot detect atoms or monatomic ions because single atomic entities contain no chemical bond. Aqueous solutions are very difficult to analyze by it, like water is very strong IR absorber, and it cannot detect molecules comprising of two identical atom symmetry such as N2 and O2. Complex mixture or samples give rise to complex spectra. Due to this, these complex mixture cannot be studied through FTIR. Thank you. That was all about my presentation.